Hello everyone, I am Juhi Gaur from Department of Computer Engineering, Silver Rock University. The subject is data structure and this video is about Unit 1 Introduction to Data Structure. In this video, we are going to learn about data management concepts, data types like primitive data type, non-primitive data type, types of data structure like linear data structure and non-linear data structure. We are also going to learn about performance analysis and measurements as well as time analysis of algorithms and space analysis of algorithms. Before starting about data structure, we should know about the data. So what is data? Data is basic facts or entity that utilized in calculation or manipulation. There are two different types of data, numeric data and alphanumeric data. Numerical data is the data which is in the form of numbers. These numbers can be count of objects, number, or any data which uses numbers. For example, 123, 365, 2024. These are the examples of number. Data that is both letters and numbers are described as being alphanumeric. For example, alphanumeric data can be 1A, 2B, 3C, or it might be ABC 1, 2, 3. When a programmer collects such types of data for processing, she or he would require to store them in computer systems' main memory. The process of storing data items in computer's main memory is called the representation. Data to be processed must be organized in a particular fashion. This organization leads to structuring of data. Hence, our mission is to study data structure. So now let's see what is data structure. Data structure is a representation of logical relationship existing between individual elements of data. We can say in other words that a data structure is a way of organizing all data items that consider not only the elements stored but also the relationship to each other. The figure is showing various data items and their relationship with each other. We can also define data structure as a mathematical or logical model of a particular organization of data items. Data structure mainly specifies the four things: organization of data, accessing methods, degree of associativity, and processing alternatives for information. Organization of data or data organization is the practice of categorizing or classifying data to make it more usable. Similar to a file or folder where we keep important documents. You will need to arrange your data in the most logical and orderly fashion. If we talk about the accessing methods, we could have the different methods using which we can access our data. It could be sequential, direct, or it could be indexed. Each method has its own advantages and disadvantages. So deciding on one or another, depending on the types of applications or nature of the data, we can use any of them. If we talk about the degree of association, then it is specifying how many blocks are there in each set, or we can say that self-associative cache. Associativity is usually a power of 2 to simplify the hardware, but other associative can be possible. So, the storage structure is basically the representation of a particular data structure in the memory of a computer. And file structure is the storage structure representation in the auxiliary memory. For example, array, stack, queue, tree, these are the example of storage structure. When we combine data structure with an algorithm, we can create a program. Data structure has many different uses in daily life. There are many different data structures that are used to solve different mathematical and logical problems. By using data structure, one can organize and process a very large amount of data in relatively short period of time. So let's look at the different data structures that are used in this different situations. So here is the classification of data structure. Basically, there are two types of data structure: primitive and non-primitive. Primitive data structures includes data types like integer, float, character, boolean, etc. Non-primitive data structures are categorized in two types: linear data structure and non-linear data structure. If we talk about the linear data structure, that are basically categorized in two types: static data structure and dynamic data structure. Static data structure includes array. Dynamic data structure includes linked list, stack, and queue. Non-linear data structure is categorized in two types: tree and graph. So we are going to see all of them one by one. So first of all, we will learn about primitive and non-primitive data structure. Primitive data structure are basic structures and that are directly operated upon by the machine instructions. We can say that primitive data structure is a fundamental type of data structure that stores the data of only one type. Integer, float, character, pointer, these are the examples of primitive data structure. Non-primitive data structure is a type of data structure which is a user-defined that stores the data of different types in a single entity. These are derived from primitive data structures. The non-primitive data structure emphasizes on structuring of a group of homogeneous or heterogeneous data types. Homogeneous is equal to, we can say that if all the data are having similar data types, then it is called homogeneous. Heterogeneous data types could have the different data types. Examples can be list or file. Here we have defined the non-linear data structure. First of all, we'll see about the array. So, array is a fixed elements of similar data type. In other words, we can say that array are defined as a collection of similar types of data items stored at the continuous memory locations. It is one of the simplest data structure where each and every data elements can be randomly accessed by using its index number, and its index will be started from 0. In general, we can say that if we wanted to store marks of students in 6 subjects, then we don't need to define a different variables for each and every marks of different subject. Instead, we can define an array that can store marks in each subject at the continuous memory locations. If we talk about array, each and every element in array will have a similar data type. If the data type is integer, we can say that it is having the 4 bytes. Arrays are useful because sorting and searching any of the value in array is easier. Arrays are best to process multiple values quickly and easily. Arrays are good for storing multiple values in a single variable. As computer programming requires large number of data of a similar data type multiple times. To store such amount of data, we need large number of variables. It would be very difficult to remember name of each and every variable. If we use single name for all those collection of variables, then it will be easier to access those data. Another is list. List is an order set containing variable number of element. For example, if we have 5 numbers, then each and every numbers can be stored in different variables. But if we create list of it, it will be very easier to access each and every variables. So we can see the list can be defined as an abstract data type in which the elements are stored in the ordered manner. So we can easily and efficiently access each and every elements. Another is file. So file is basically collection of logically related information. It can be viewed as a large list of records containing various fields. So in simple words, we can say that file is a container in computer system that stores data, information, settings, or any kind of commands which can be used in computer programs. So in GUI, we can say that Microsoft operating system represents file as an icon which associate with each and every program. If we click on this item, the file can be opened. We can see the figure where we are having array, list and file. Array is containing 5 elements in our figure. If we talk about list, it is also containing the 5 elements, but it is basically referring the next element. We can also see the file structure in figure, where we are having various list of reports which in the form of file. Now let's learn about linear and non-linear data structure. Linear data structure. A data structure is said to be linear if its elements are connected in a linear fashion by means of logical or in sequence memory location. If we talk about linear data structure, stack and queue Both are the example of linear data structure. Stack, we can say that if we are keeping various dishes on each other, then at that time when we put very first dish, it will be in the, we can say, last position. If we put another dish, it will be over that first dish. So we can say that stack is basically last in first out fission, because when we are taking off the dishes, we start taking off the very last dish first. Another is queue. If we talk about queue, it is the FIFO structure. FIFO stands for first in first out. It is like the normal queue in the multiplex where we wanted to buy the tickets. Whosoever goes first will have the ticket first and go for the movie first. Non-linear data structure. Non-linear data structure are those data structure in which data items are not arranged in a sequence. For example, non-linear data structures are tree and graph. Tree is a non-linear data structure which are going to have the various nodes. The very first node will call the root node and the very last node will call the leaf node. Graph is basically collection of vertices which are connected with the edges. So here is the figure for stack, queue, tree and graph. As we have seen briefly that stack is a data structure that follows the principle of LIFO, means last in first out. All the operations in stack are performed from the top of the stack, as we have earlier seen the example of dishes. Operations like push and pop will be performed on stack. If we insert data into the stack, it's called the push operation. If we are removing any elements from the stack, it's called the pop operation. So we can say that the stack is implemented either using the array or using the linked list. If we talk about queue, queue is the data structure that can be implemented in the form of FIFO. We can use array to implement the queue. If we talk about the basic difference between stack and queue, then we can say that elements in queue will be inserted from the rear end and elements in queue are removed from the front end. As we have earlier talked example of the multiplex queue. As well as we have talked about tree, that tree was the basically non-linear and hierarchical data structure where we can say these elements are organized in the tree-like structure. The topmost element is called the root element and each and every other will call the nodes. We can store various kind of data in each and every nodes. It can be of any type. If we talk about graph, graph is the non-linear data structure which is connected with each other with the edges, and this can be called vertices or nodes. We can say that graph is consist of finite set of vertices as well as each and every pair of vertices will be connected with edges. We can say the graph is used to solve the most of the challenging and complex problems of computer system. Now let's learn about the operations of data structure. The first operation is create. Create basically reserves memory for program elements by declaring them. So it results in reserving memory for program element. The creation of data can be done during the compile time or might be runtime. We can use malloc function of C language for creating the data structure. Another operation is destroy. It destroys memory space allocated for specified data structure. Free function of C language is used to destroy the data structure. Selection. Selection selects specific data from the present data. You can select any specified data by giving condition in loop. So basically it deals with accessing a particular data within a data structure. Updation. It updates the data in the data structure. You can also update any specific data by giving some condition in loop like select approach. Next operation is searching operation. Searching means to find a particular element in the given data structure. It is considered as successful when the required element is found. Searching is the operation which can be performed on data structure like array, linked list, tree, graph, etc. So basically it finds the presence of desired data item in the list of data items. Next operation is sorting. It is a process of arranging all data items in a data structure in a particular order. The order can be ascending or maybe descending. We can take the help of many sorting algorithms to sort data in less time. For example, bubble sort. There are many other algorithms that can be sort data effectively like merge sort, insertion sort, selection sort, or maybe quick sort. Next operation which we can apply on data structure is merging. It is a process of combining the data items of two different sorted lists into a single sorted list. Next operation is splitting. If we talk about splitting, it is basically process of partitioning single list into multiple lists, dividing data into different subparts to make the process complete in less time. And the very last operation is traversal. Traversal is basically visiting elements when it is sorted. We can say that it visits data in a synchronous manner. This can be done in any type of data structure. Now let's see about the time and space analysis of algorithm. Generally, there are more than one way to solve any problem in computer science. We can use different algorithms on one problem. Therefore, it is highly required to use methods to compare that the solution is optimal. We need to learn how to compare the performance of different algorithms and choose best possible way to solve particular problem. In other words, we can say that the time complexity is how long a program can take to process a given input. The efficiency of an algorithm depends on two parameters. While analyzing an algorithm, we can most consider the time complexity as well as we can consider the space complexity. Space complexity is defining that how much memory space the particular solution will occupy. It also has to be in the optimal manner. If we talk about algorithms time and space complexity analysis, then the time complexity of an algorithm quantifies the amount of time taken by algorithm to run a specific function which is having this specific length of input. The valid algorithm takes a finite amount of time for execution. The time required by the algorithm to solve given problem is basically called the time complexity of the algorithm. Time complexity is very useful to measure algorithms analysis. It is the time needed for the compilation of an algorithm. To estimate the time complexity, we need to consider the cost of each and every fundamental instructions as well as number of times particular instruction is executed. Next is the space complexity of an algorithm. Problem solving using computer requires memory to hold temporary data or final result whenever we are executing any program. The amount of memory required by the algorithm to solve given problem is basically called the space complexity of an algorithm. Space complexity is basically defining the amount of space which is required by the algorithm to run any specific function of fixed length of input. For example, suppose a problem to find the frequency of array element. It is the amount of memory needed for compilation of an algorithm. Then, if we talk specifically about time and space complexity, it is depending on the lots of things like hardware, operating system, and processors. However, we didn't need to consider any of these factors while analyzing the algorithm. We will only considering the execution type of algorithm. Now let's learn how we can calculate time complexity of an algorithm. Time complexity is most commonly estimated by counting the number of elementary functions performed by the algorithm. It is because the total time took also depends on the some external facts like compiler used, processor speeds, etc. Since the algorithm's performance may vary different types of input data, hence for an algorithm we usually use the worst case time complexity of an algorithm because that is the maximum time taken for the input size. As of the worst time complexity is defining that if we have more amount of data and a vast input size, then we could have the more time for the execution. Here we have the example that how we can calculate the time complexity of sum of elements of list which is using the one-dimensional array. So here we have the function called sum of list which is having two parameters. One parameter is a which is defining array and another is n which is basically defining number of elements in array. If we see the line number 1, it is saying total is equal to 0, whose cost is basically 1 and which will be executed only once. In the line number 2, we have defined it for I is equal to 0 to n minus 1, whose cost is basically 2 and which can be executed n plus 1 time. Because we are starting with the 0, it will take the execution time n plus 1. And the line number 3 is defining total is equal to total plus a of I. whose cost is 2 and the execution time will be n. As of it will be iterating n number of time. And the fourth line is written total, whose cost is 1, and obviously it will going to execute only once. So if we wanted to calculate time complexity is the basically summation of product of cost and number of time it is executing. So we will do summation for each and every one. Here we are going to have the summation. So 1 plus 2 into n plus 1 plus 2n plus 1. If we do the product and summation of this stuff, we are going to have 4n plus 4. We can neglect the 4 as it is constant. So the time complexity of given algorithm is n unit time. So here we have completed our unit number 1. Thank you for being there.